So in this example, as you can see, the software origin and the part origin or the part corner are not aligned, right? It's somewhere else. So in this case, I mean, generally what we do is we just translate the part to the software origin and then work from there. But let's say if we don't want to do it for any reason, then we can basically establish origin uh, at the corner or at the location where the part is. So that's how you can just move your software origin temporarily, you could say, just for that part. So how we do that is that you can go to the planes here, and so I'm gonna just copy that top plane. So right click and create duplicate. So now we have a duplicate of the top plane, say top one, right? We're gonna just make it active as a work coordinate system, construction plane, and tool plane, all of them. Yeah, so here now we can pick the origin. It won't let us do to the original views because that's kind of software standard view. So you have to create, uh, you can say, auxiliary view to do that. So now I would just pick that point, and now I would say that my part is here. So again, now we have uh, that icon on my mouse. Again, from the selection, I would pick the intersection option. Just explore that. Intersection and intersection of this entity and this entity, right? So now as you see, the origin sign is moved and showing it on the part corner, right? So basically those are the numbers, so that is shifted with those numbers. So x 1.9657 and so forth, and y 3.3356. So that's the difference between software home and the part home, you can say. So now when we create a program, the software will calculate all the numbers from this newly established origin. So for example, if I go ahead in toolpaths, you go to toolpath. If I try to create one toolpath, just for example, and just undocked it. Let's put it back here. Okay. Uh, so if I go create a drill toolpath, let's say, and I'm going to just create one drill right here and say OK, and yeah, select tool. Yeah, so I'm just to prove the concept, I would just go ahead, just accept the numbers. So just give it a depth, maybe negative zero point 0.2, and then say OK. And now I would just post that and see what kind of codes we are getting. So now if I post it, just save it as a test or T. Yeah, overwrite it. Okay, so if we analyze the codes, look at the position where we are drilling that hole is at x 0.7367 and y 0.7815, and it is matching to the numbers as per dimensions on the part. Right. So what basically the codes we are getting are calculated from the part origin, not the software origin, because we specified them in the planes and it's kind of temporarily moved it to the part corner. Now let's look at this example. If we have more than one fixture on the machine, could be two vices or could be two fixtures, and we wanted to machine both of them in the same setup at the same time. Right? I mean, it could be that you wanted to run two of the similar part, or maybe it's the same part, but we are running, two operations, uh, and on in one fixture you are running op one, and the other fixture you are running op two. So all those scenarios can be addressed the same way. All right. So for the part on the left side, I'm gonna just again create another copy or duplicate. So it calls top two, right? Now, when we were at top one, it uh, gave us the work offset here, -1, which relates to G54. Now, when we are at top two, I'm going to just make it active. Um, this time, we're going to just manually call it, I would just call it 1. Okay. Now, again, this time we would pick up the origin at the intersection one more time, intersection of this and this. So now as you can see, our plane 2, top plane 2 is basically that far away from the software origin. Right? So all our numbers will be still calculated from the part origin where we have it. All right, so that's all done. So now we can go to toolpath, uh, and I would just create another drill toolpath. So if I go to toolpath drill, because this time we're going to be using that newer uh, part on the left. Okay, so one more time, I'm going to just pick uh, the center, say OK, and yeah, the only thing we give is linking parameters. Make sure we have some depth in there. It's already coming from the previous operation. So yeah, I would just say OK, and just, and we can see that the drill operation is created there. All right. So now let's see if I post both of them. We wanted to see how our results are, how what coordinates we are getting in the G codes. Okay, I'm just gonna overwrite this T program. All right. So if you look at the codes now, see with G54 on part number 1, the coordinates we are getting as per our dimensions, and the same with G55, that part number 2, we are getting the same number, same coordinates. So basically, the by changing work offsets, we can run both of these parts together. All operator have to do is just pick up their respective corners and enter those information in their respective work offsets, right? G54 and G55. So you can see both of them are basically the coordinates we are getting from the part origin. Another possible scenario could be when you have a part where you have some detail on any of the side. It could be right side, front side, back side, wherever it is, right? So we can, without copying and rotating the part, we can do the toolpaths within the same setting by using work coordinate system. Okay, so let's try to drill the hole on the side of this part. So again, because this is on the right side, so I would just here in the planes menu, I would create a copy uh, duplicate of the right side. So now we have there. Let's make that active, and we're gonna give this to offset number 2, so that we get a different work offset for that. And for the position, I would just pick this corner, right? So there is a point already on the intersection. If I zoom it in, you can see it. I just created it before. So I'm gonna just pick that point there as our origin, right? So it's already updated in the planes menu. Now, if I just update my view here, isometric again, you see it brings that view up as a as our z-axis. So it's already orienting. It's just thinking it in a way that this is how we will be basically setting it up in the machine. So by looking at the top view, uh, you see this is how it will be in your machine, and you see the corner which will be the work offset for our setup. All right, so let's go ahead, go to isometric, and then one more time I'm going to just and go to toolpath, and we would create another drill toolpath. In drill, I would just pick the center, and I would just say okay to everything else because we have all the parameters in there already, right? So just let's regenerate it. That's fine. I'm good. There is our drill toolpath created already. You can see it there. All right. So yeah, basically now it will give us a different work offset for the side hole, and uh, yeah, I can just set up a third vise, and that's install that plate the way it is showing on the screen with that orientation, pick that corner, and go from there. So let's just now post all three of them together and then see. Okay, can just go ahead. Okay, fine. Let's use the same post. Let's overwrite that, the same program. Yes. Okay. So now if we look at the codes, you can see there is G54 coordinate right here, and then G55. They are exactly the same as G54 because we picked up that corner. G55, sorry, and then G56. That's the coordinates for the side hole. So as per our view in this on the screen, that from that corner, that's the distance of that hole. So you see, by using the work coordinate system, you can accomplish more than one setup. There could be the same part, or there could be operations on, different sides of the same part. You just set them all up, pick a different work coordinates, and then establish your WCS in the CAM, and it will post all the G codes accordingly. Okay. All right, here we are. Once again, both the parts uh, showing in the orientation as per our uh, WCS. So if I go to planes again and make my top view as active and then update my views, then it will show it as normal. So now if I go to, so, right, so it will be updating the screens, uh, your view as per your active level or active WCS. We are not limited to use existing views and copy pasting it, but we can also create uh, customized work coordinate system if you need to. For example, in this part, if we wanted to machine something on this face, right, on this 45-degree chamfered face, what I would do is we can create a WCS on that face basically. So I would just explore this here and create a customized WCS. So yeah, as you can see, there are few options. You can create it by geometry. If you have a 2D geometry, you can pick two lines or points to create a WCS. We can also create by the solid face. So in this case, we would try that option by solid face. Now, we wanted to machine something on this solid face, so I would just click it there. And now it gives us few options. So basically, we have 8 options for that WCS. So if I rotate it around a little bit, you see that. So that X, Y, Z direction on the icon basically is showing, or it's asking us how this part will be oriented on the machine. So which way will be X positive and Y positive, right? If this is good enough, if that's how it is going to be set up in the machine, then we leave it like that. Or I can just going to go to option number 2. So now it says the X positive is going to be this direction and Y will be there, right? Another option. So yeah, so we have all these options. So most likely it's gonna be so Z, we want it to be on the looking towards the top for sure, right? Like that. So it is the only point of discussion is that how your X and Y will be oriented. So if this plate, I'm holding it in the vice uh, prob, and the vice is clamped, uh, in a way we generally do on the machine, like handle towards the operator, then probably this is the right choice because our X positive will be towards the left, and Y positive will be away from the operator, and Z positive looking upward, right? So that looks like the more um, a practical way. So yeah, I will just pick that, say okay. Right. Now here again, we can update this information, the X, Y, Z points. You can pick it as per, if you wanted to use a different corner, we can do that too. But right now it's picking up in the middle. So I would just say okay. And see it created that customized plane right here. Now if I make that active, and let's say we're going to be working from a corner, then I can just specify that position as my origin point, right? And now we have that plane again. Yeah, we can customize the names and we are good to go. Now if I update my view, you see it would basically, that's how we will be setting it up to machine something on that face. So let's look at from the top view. There it is, right? So that's how it will be in your machine if you hold it in the vice. Uh, X positive towards the left, Y positive away from the operator, and Z positive looking upward. Right. So just wanted to bring it up that you're not limited to using the standard WCSs, but we can also create a customized one uh, as per our need. Just the last note about the planes, that we can actually customize their name according to uh, our use. So, for example, this top one and two, uh, I can maybe I can go right click on it, add it, and then I can say the right part, right side part, right? I can say that right side and update. And similarly, I can see the name is updated. So similarly, I can do the top two. We can add it as well, and I would say it left side. All right. So that's how you can customize the names as well, name of the views. That brings us to the end of this lesson. I hope it was helpful. Let me know if you have any questions.